All right, welcome back, Hononegah Honors, Algebra 2, Chapter 8, review questions now. Um, Chapter 8 is all about the formulas. So the formulas that you will be given will be arithmetic sequences and series. So writing the equation or the model for an arithmetic sequence or finding the sum of an arithmetic series. Same with geometric and then infinite geometric. So there's formulas. These will all be given to you. They'll be on a separate sheet of paper, so you won't have to memorize that. So this should be very helpful as we go through all of this. So again, we might have to come back and reference this page here in just a little while. To start the chapter off, however, we did not know if it was arithmetic or geometric. We had to just come up with a rule. So notice in the directions just says write the rule of the nth term. So I'm looking for, is it geometric? Is it arithmetic? I'm looking for a pattern here, and then I'm going to try to write an equation for that pattern. So the first one, it adds 3, it adds 5, it adds 7, it adds 9. So therefore, it's not arithmetic. So we can take that one off. Multiplying, multiplied by 2, and then the next one multiplies by something a little less than 2. So it's not geometric either. So I got to come up with a rule here on my own. And this gets a little bit more complicated. So 1, 2, 3, 4, 5. And so I'm looking at those and I say, well, if I square them, if I have n and I square it and add 2, does that work for all of them? So 2 squared plus 2, and 3 squared plus 2, and 4 squared plus 2, and 5 squared plus 2. So yes, as long as it works for all of the terms that you see, then that is the rule that you can write. So that's a little confusing because there isn't necessarily a set formula. So the next one, 2 thirds, 2 sixths, 2 ninths. So this is the first term, the second term, the third term, the fourth term. So it looks like as long as I have a 2 on top, and I take 3n on the bottom, that should work. So again, I am coming up with a rule for each of the terms as it goes dot, dot, dot. So there is no necessarily formula to use here, which a lot of people don't like. They just want a formula. Find the sum of the series. Again, not using a formula here. They're giving you 1 to 6 and they're giving you equations. So I need to know if when I put 1 in, I get 3 plus. When I put 2 in, I get 4 divided by 2, which is 2. When I put 3 in, I get 5 divided by 3. When I put 6 in, I get, sorry about that. I put 1 in, I put 2 in, I put 3 in, I put 4 in. That's what I meant to say. So I get 6 divided by 4. I'm just going to leave it as 6/4. It does reduce. When I put 5 in for n, I get 7 divided by 5. When I put 6 in, I get 8 divided by 6. Add that up. So I'm going to pull out a calculator, and I'm going to find the sum of the series. So again, I'm just putting individual numbers in, 1 through 6 in for n. So 3 plus 2 plus 5 thirds plus 6 fourths plus 7 fifths plus 8 sixths. And I get 10.9, which as a fraction would have been 109 tenths. So either one of those would be correct. Again, this is just the sum of a random series. Now we're going to do summation notation. Here's what that means. Is 1, 2, 3, 4, 5 terms. So summation notation from n to 1 to 5. So there's 5 terms. And now I have to actually write the rule. So what's happening each time? Well, it looks like they're adding 3 every single time. So 3n, so 3n plus 4. Would that work for each one of those? Sure it would. Okay, put 1 in for n, I get 7. Put 2 in for n, I get 10. 3 in for n, I get 13, and so on. So that is what the summation notation would be for this particular situation. Next one. There are 1, 2, 3, 4, 5 terms. So I'm doing a summation notation from 1 to 5. And now I got to write the rule for this. Now, I notice that it's going back and forth. So we're talking about -1 to the nth power. And then you're basically timesing that by n plus 2. So put a 1 in. Does it work? Put a 2 in. Does it work? Put a 3 in. Does it work? And it does for all of those. So again, writing a rule and then putting it in summation notation for the numbers that you have. So that can be a little confusing. That's section 8.1. It's probably actually the hardest section in this particular chapter. All right, we'll keep going. Now, just state whether the sequence is arithmetic, geometric, or neither. Arithmetic, it has to add or subtract the same number. Geometric, it has to multiply. Sorry, a little confusing there. Let's try that again. Add or subtract the same number. Has to multiply by the same number. Or if it doesn't do either one of those, we're going to say neither. Only reason you would have to explain your reason is basically saying it's adding something each time, or it's subtracting something each time, or it's multiplying. That's what it's asking for when it says reason here. So this one, -3 to 3/4 to negative. So it looks like it is multiplying by a -1/4. Let's see if that's true. Multiply by -1/4, multiply by -1/4, and so on. So this has a common ratio, making it geometric. And your reason is right there. It has a common ratio. Next one, looks like it's adding 0.7 each time. Therefore, that makes it arithmetic. And your reason is just like that. You have to add. It's got a common difference. Next one's adding 1, adding 2, adding 3. Although it is a pattern, it is neither. And the last one looks like it's multiplying by 3. So it has a common ratio of 3, therefore making it geometric. This is going to get a little bit easier for some people now because, again, it is telling you, find whether or not the sequence is arithmetic or geometric. And once you know it's either geometric or arithmetic, then you're going to write the rule. So the first one here, it's subtracting 4. I apologize coming back here. The bells were ringing. So there's a common difference here. It's subtracting 4 each time. So I want to write the rule. In order to write the rule, going back to the formula sheet, a sub n is equal to a sub 1 plus 1 minus n d. So that is the arithmetic formula if you want to go back to the formula sheet. So all I need to know is what is a sub n and what is d. Or excuse me, what is a sub 1 and what is d. So a sub 1 is 7. And d is -4. Distribute. So distributing the -4, so -4n plus 4, and then adding like terms. So there's the rule. So I wrote the rule. Now, using that rule, they want me to find a of 16. So a of 16 would equal -4 times 16 plus 11. So -64 plus 11 would be -53. Next one, find whether the sequence is arithmetic or geometric. And I don't think I put it in here, but you do need to write it. Arithmetic. So the next one, it is multiplying, but it's multiplying by kind of a weird number. So it is geometric, but figuring out what it's geometric, because it's not adding or subtracting the same number each time, it's actually multiplying, and it's multiplying by a half, so that makes it a little bit harder. Formula, a sub n is equal to a sub 1, r raised to the n minus 1 power. So all I need is what is a sub 1 and what is r. A sub n would equal a sub 1, r raised to the n minus 1. So there's the rule. Next, they want me to find a of 16 again. So a of 16 would be 96, 1/2, 16 minus 1. So now this one's a little bit, you're going to probably need a calculator for this one for sure. So 96 times a half raised to the 15th power. And so I got 0.0029. Now, if I ask it to do it as a fraction, it's 3 over 1,024. So just letting you know, I will accept either one of those answers. Obviously, the fraction is a little bit more accurate. You didn't round. Write the rule for the arithmetic. So now it is telling me it's arithmetic. In order to write a rule for arithmetic, you need two things. You need the a sub 1 and d, but it's not giving you that. Okay, it's giving you a sub 11 and d. So what does that mean? That means when you get 43, the 11 is the end value. Solve the equation for a sub 1. So 50, subtract 50, a sub 1 is negative 7. So now I do have enough information. I know a sub 1 and I know d. So when I distribute and add like terms, I get a sub n is equal to 5n minus 12. Next one, write the rule again for the arithmetic, and they're not giving me very much information here. Okay, they're not giving me d, and they're not giving me a sub 1, so they're not giving me anything. I need to then write two equations, one for each one. So negative 8 would equal a sub 1 plus 6 minus 1d. So negative 8 equals 5d. Second one, negative 62 equals a sub 1 n minus 1, 15 minus 1d. What this creates is two equations with two unknowns. So if I multiplied this one, let's say by negative 1, I would get positive 8, negative a sub 1, negative 5d. Cancels. D would equal negative 6. So now that I know D, I can come back up here. A sub 1, negative 6 times 5 is negative 30. Add 30, I get 22. So now I have enough information to write the equation. A sub n equals a sub 1, n minus 1, d. Distribute. And so I get plus 6 plus 22 would be plus 28. So that's a little bit, that's about as tough as this gets as far as actually having to write an arithmetic sequence rule, is if they don't give me a sub 1 and they don't give me d. Next one, find the sum. There's a formula now, and I'm going to go back up here to the slide. So the formula for an arithmetic is n, a sub 1 plus a sub n over 2. So again, the first term, the last term, divided by 2. So let's go back now all the way to the bottom. I'm going to write this down, n, a sub 1, a sub n, and 2. So in order to find the sum of an arithmetic sequence, you need the first term, you need the last term, and you need how many terms? So let's talk about the first term. I'm going to put 1 in for n and get negative 1. So there's the first term of the sequence. I'm going to put 20 in for n, and that's the last term of the sequence. And how many terms are there? There are 20 terms from 1 to 20. 20, first term, last term, divided by 2. So 20 times 36 divided by 2 would be 18. 20 times 18 is 360, is the sum of the arithmetic sequence. Now we're talking about geometric. So again, going back to the formula, a sub n would equal a sub 1, r raised to the n minus 1. So the two things that you need in a geometric sequence is what is a sub 1 and what is r. So right off the bat, they don't give me a sub 1. So they give me 3, we don't know a sub 1, we do know r, and we do know that n is 5 for this particular situation. So I got negative 1/3 raised to the 4th. Take negative 1/3 to the 4th power, I get 1/81st. Multiply both sides by 81. So 81 times 3 is 243. So now that I do know a sub n, or excuse me, I do know a sub 1, and I do know the r, I can write a geometric sequence. Next one. Write the rule for the geometric, and again, they don't give it to me, and now they're even getting harder because they don't give me either a sub 1 and they also don't give me r. So now I got to play these scenarios out. So negative 72 equals a sub 1 r raised to the 2 minus 1, which is just 1. The second situation is negative 1/18 equals a sub 1 r raised to the 6 minus 1, which is 5. Solve each of these for a sub 1. So I'm going to divide. So I get negative 1 over 18th r to the 5th. And this one is negative 72r over is a sub 1. Create a proportion. These two would be equal to each other. So negative 72 over r would equal negative 1 over 18 r to the 5th. Cross multiply. So I'm going to use a calculator now. 72 times 18. So negative 1,296 r to the 5th equals negative 1 r. So I want to divide both sides by r to get the r's on the same side. So negative 1,296 r to the 4th equals negative 1. Divide by negative 1,296. So r to the 4th equals 1 over 1,296. Take the 4th root of both sides. So now, using my calculator skills, I'm going to take the 4th root of 1,296, and I'm going to get 1/6. So the r is 1/6. Now I'm going to go back over here and put r back in. So negative 72 divided by 1/6. And get negative 432. So my rule for this geometric is a sub n would equal negative 432 times 1/6 raised to the n minus 1 power. Find the sum. Now, again, you probably are going to have to go back. So let's go to the formula sheet here. Let's go back and see what we got. Sum geometric. Right here. And that's a hard one to remember, which is why we go ahead and give that to you. A sub 1, 1 minus r raised to the nth over 1 minus r. So I'm going to go back to that slide now. I'm going to write that down. So S of n equals a sub 1, 1 minus r raised to the nth over 1 minus r. So the three things I need to know. I need to know what a sub 1 is. I need to know what r is. And I need to know what n is. So let's look at this. A sub 1. If I plug 1 in for k, I get 4. Now, you can go ahead and find some terms, but it's going to be, the rate is going to be 3, because that's what's raised to the k minus 1 power, and there are 9 terms. So now I know enough. So 1 minus r raised to the 9th over 1 minus r. Little calculator time now. 1 minus 3 to the 9th. Is negative 19,682. So now divide that by negative 2 and times that by 4. I get a sum of 39,364. And by the way, it's a little messy here to write. I'm going to change that. It's supposed to be 9682. There's a big parenthesis. Next one. Find the sum of the infinite. Again, formula. Sum, it's a partial sum. It's a sub 1 over 1 minus r. So now the only two things I need to know is what is a sub 1. So when I put 1 in, I get 12. And what is the r? Well, the r is the 1/3 being raised to the k minus 1. So a minus 1, 1 minus r. Little calculator work here. I get 18 as the partial sum. Sum of the infinite geometric series. Now, it's multiplying each time by 1/5. So can I do it or not? That's the first thing you got to ask yourself, and the answer is yes. Anytime the ratio is between 0 and 1, it'll work. So a sub 1, I have enough information. Sum of a partial infinite geometric series is a sub 1, 1 minus r. So now, doing a little mathematical work here, 2 divided by 4/15 is 10/4. So I multiply by the reciprocal, and I reduce that to 5/2, or 2.5. Repeating decimal, here's what you got to ask yourself. How many decimal places are they repeating here? Well, they're repeating 2 decimal places, so that's a rate of 1/100th. And the 0.37, your a sub 1, is 37/100ths. So I can do this, and you notice it says here, must show work. You cannot just put this into your calculator and get the answer. So a sub 1, 1 minus r, so 37/100ths over 99/100ths. Anytime you multiply or divide by a fraction, you multiply by the reciprocal, and that cancels the 100ths. This does not reduce, and therefore that is the correct answer, 37/99. So if you type in 37 divided by 99 on your calculator, you're going to get 0.37 repeating. Next one. Physics experiment. A steel ball on a flat track is accelerated, then allowed to roll freely. After the first minute, the ball is 120. Each minute is 40%. So my R is 40%, or 0.40. This is basically as far as it did as far as it did from the preceding minute. So my a sub 1, 1 minus r. This is an infinite geometric sum. So I get 120 divided by 0.60. So this particular physics experiment steel ball traveled roughly 200 feet. Please make sure you look this over, study for your test. This is actually a test that a lot of students do well on. So please make sure that you are paying attention, and good luck.